Hello, good morning. I think we are earlier than before, so 10 minutes faster, 10 minutes earlier. So I just want to continue from where we stopped last session. So the last time we were able to talk about different net frameworks and then Solidity itself, and then Ita.js, which is a library. Um, I in this In today's lecture, we are going to be talking about um, some nitty-gritties of Solidity programming and then ICP, Internet Computer, so blockchain. So I will just try to take you. Good morning, everyone. So I will try to take you through the step-by-step procedure, talking about the internal workings of Solidity. Then after that, I will go more deeper into um, internet computer blockchain. So in order to do that, I will need your attention, and then I will also need you to be able to like be live, like go on Remix, load your Remix, and then let's see how we can just interact together and get this done. So come in, let me go to this to the ICP. Okay, that's it. Now, on the section of ICP, we are going to talk about the overview of the ICP blockchain and its future. And then I think everyone is already familiar with Solidity, with Ethereum network, Ethereum smart contract, Ethereum blockchain. I mean Ethereum blockchain. So um, ICP also use Solidity, and then the main objective for today's lecture is Solidity itself and ICP. So I just want to make sure that you are able to get a grasp on how this ICP blockchain, Internet Computer blockchain, how you can write smart contract on it. And then before you can do that, you have to understand the programming language called Solidity. So let's go to this section. Um, okay, all right. So we want to build a storage factory contract to manage multiple simple contracts. So I think last week I was trying to show you some documents, some documentation about TAGS and then Solidity and Remix and the documentation of Remix ID, and now you can use it properly. Hope everyone can hear me. Hope I'm loud enough. Hope I'm audible enough. Can you hear me clearly? I I'm not I'm not able to signal. There's no signal for the audio here, so I feel like if you can hear me, you should signify. Okay, let me just okay. So I want to uh, ask you whether if is there anyone that actually gone through that they, if you have tried your hands on the remix ID from last week. Can you just say, just like do a remix, just type remix, yes, remix, yes, remix. So I want to know how many people already gone through remix or try to like understand. It's not necessarily you write a code, But if you just go straight to remix and try to understand the whole uh, architecture inside remix and how you can use it how you can use remix to actually write a program. Okay, that's good. That's good. Um, what's it called? Okay, that's very good. I'm glad you did. Okay, you did not do, but I will try my best to step a bit backward and then explain. But I won't go too deep like last week. But I will just paraphrase the whole concept of remix, and then from there I will go straight to solidity. So, but in the you can see um inside the slide here, we're talking about building a storage factory contract to manage multiple simple contracts. So creating a fund me contract for crowdfunding. So this is like the three objectives that we want to cover, and then by doing this, we can also do the same thing for ICP blockchain. This is ICP blockchain. Yeah, this ICP blockchain. We can do the same thing for the same contract that we are going to write here. We are going to also deploy it on the ICP blockchain. So what is ICP blockchain? ICP, what's it called? ICP blockchain is a kind of internet computer that allows us to be able to build like more realistic, computationally intensive, what's it called, softwares on the blockchain network. So when you want to write some type of software that are actually computationally intensive, like artificial intelligence now, so you can actually build some pattern recognition softwares like um, LLMs or computer vision systems on ICP. So this is a kind of what's it called? Let me just like give you a let me give you a kind of I want to give you a framework. I want you to have this framework when you are thinking about ICP. This blockchain protocol is a blockchain protocol. So the internet computer is created to um, it is created to actually replicate state machines. Like it's kind of like I've said earlier with Ethereum network. Ethereum network is kind of based on this ledger peer-to-peer architecture. But in this ICP, the only main thing here that is different, that is making it different from Ethereum network. Um, okay, I'm trying to load my remix up here. Okay, so okay, I think the remix is loading now. Yeah, okay. So once my remix is up, I will start sharing. So please try to load your own remix too, so that you can go along with everything I'm doing. Now, there are some. Before I move on, I want to explain ICP blockchain protocol and Ethereum blockchain protocol. But the most important thing I want to talk about is the difference I want to compare both Ethereum and ICP. So Ethereum is very popular. Ethereum blockchain is very popular, but ICP is what's it called? Let me start with Ethereum. Ethereum is a decentralized platform for smart contracts, which are self-executing contracts with the terms like the code are directly they are autonomous in their way. They are like decentralized applications. But what's it called? ICP is like more of like more scalable um, blockchain network. So when I mean scalability, I mean that there are some systems that rely on cloud infrastructure. Okay, they rely on cloud infrastructures that you will need to find a way to what's it called in Ethereum. You will need to find a way to actually get what's it called. You will need to find once you deploy a smart contract, the you will need to host this. There are some operations that you can't do on chain. Like there are some computationally intensive operations that you will need to do off chain. That's when these people came on board. They call themselves chain. Is it on chain? They are. Let me try to remember their name. Uh, chain Chainlink. So Chainlink came on board to serve Ethereum networks. So they are trying to do off-chain data processing. Then after processing this data, they will now push it to the network. So that's what Chainlink was doing since. But when ICP came on board, ICP is allowing you to do all those offline data processing on the network itself. So that's one key feature about ICP. Another thing about ICP that I think is very important is the consensus mechanism. So the way ICP do consensus mechanism is called a threshold delay. I said delay. Threshold relay. So it is like this a combination of proof of stake and randomized beacon generation process. Like if you want to like kind of combine both proof of stake mechanism that is working already in Ethereum, plus the fact that they are randomizing the beacon generation process. So it's a random beacon generation process. This allows for rapid finality and high transaction speed. So now, for the Ethereum network is using proof of work and also proof of stake after the Ethereum 2.0. And then that's just like the improved version of Ethereum is Ethereum 2.0, and the proof of stake um, is not actually using a randomized beacon generation process, but it's just using the direct beacon chain generation process. So it's not randomizing it. So now the fact that anytime you want to like kind of develop a technology that there are some existing technologies that are running. Okay, you can't hear my voice. Okay, I don't know. So let me wait a bit. Let me wait a bit. Maybe once network is back. But let me just go on. You can still see this video online. So Ethereum has a lot of issue with scalability, and then Ethereum 2.0 is trying to address the scalability issues. But in terms of ICP, it is from ground up designed to from start designed to actually solve the scalability issue, and then so that it can run web application very fast and scalable without limitations to the amount of nodes that it can scale to. So that transactions can be processed faster on the ICP network. Now, another thing is data storage. How ICP is able to store data compared with how Ethereum is storing its own data. So Ethereum is using this built-in decentralized data storage. No, I mean ICP is using the built-in decentralized data storage that can store large amount of data directly on the blockchain. So the fact that this chain link guys I mentioned earlier, the fact that they are trying to um, okay, thank God you can hear me now. So the fact that these chain guys are trying to store your data for you so that you won't overload the network, all these issues with Ethereum has been resolved with ICP because you can store big data on ICP. You know when I mean big data, I'm talking about petaflops, terabytes, and like large data because before you have to like try to manage the space on Ethereum, and then you are trying to also manage the computational resources on Ethereum. But in this, because it's a network, so you don't want to overload the network with your computation so that your transactions can be faster. But in ICP, you don't need to worry about that. Just code as if you are using the traditional computational infrastructure. So now Ethereum Ethereum storage and data admin is Ethereum requires external solutions like IPFS, and then when you are storing data on Ethereum, you pay for it too. It's very expensive to store data on Ethereum, so you are careful on how much data you want to store on Ethereum network. So those are the issues that are resolved in ICP. So these are the things that I just want you to have at the back of your mind comparing ICP with the normal Ethereum network. So I want to also inform you that I will like to encourage you to code. I want you to write some codes today. At least I want you to run some errors and resolve it yourself. And you can DM me if you can't resolve it. I will help you out. I also want to inform you that after the lecture, last lecture next week, I will share a document, a PDF document that will contain the codes, the solution, the explanation, and everything I've been explaining in this training so far. So you can have it should be like a note for you to read and be able to understand everything I've been saying. Now, if you know about Solidity, just let me know. Foundry, that's not in the what about Foundry? It's not in the scope of this our lecture. Let's just go straight to Solidity. Um, I will answer that too when we get to, but I want to make sure because we want to get some things done today. So I will. So okay. The main thing here is that I want to go back to Solidity now. I want us to go to um, some of the okay. Let me quickly go straight to Remix. So Remix is an IDE that you use to write smart contracts. So in Solidity, and you can also write JavaScript there too. So there are some basic functionality of Remix. Let me try to see whether I can. So there are some smart contracts. Please load your remix, please. Has anyone loaded the remix? So you have been, if you attended the last lecture, you know the remix.ethereum.org. That's the address for the IDE. Please, if you have loaded your remix, just say yes. You have loaded the remix. Please, I want to give you time to load the remix IDE up because it takes some time to load up if you are just loading it up. So there are some default smart contracts already there on the remix. So I will explain the smart contracts, and then after that, then I will now like kind of try to uh, now break it down to each component of the Solidity programming language. So you have loaded your remix, right? Have you loaded your remix? Just say yes, remix. Okay. So in this, okay, the last thing on this my presentation, this module 4 is like understanding basics of editing syntax and function. So if you have loaded your remix, I want to explain some. I want to like give a briefing of some syntax and Solidity and explain the functions there. Now, so um, okay, the remix is loaded. How many people are saying yes? Now I'm still waiting for more people to just say yes. Maybe two more people to just say yes, so that um, okay, if you are just coming on board, what I am saying is that you should load your remix.ethereum.org. If you are in the last lecture, you remember when I said when I talked about remix, and then that we'll be using remix today to actually so we'll be using remix today to okay. All right. Okay. All right. Okay. 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 I'm coming. I'm trying to prepare the remix environment properly. I want to break down the functions and then get you to be able to like just pick it up chunk by chunk. So don't worry. I want to try to make it as simplistic as possible so that anyone that is just coming to join this lecture today or have never ever written any Solidity program in their course of career will be able to understand it properly and then make use of it. So Okay, nice one. Mhm. All right, I think I'm ready now. So, are you ready too? Okay, yeah. One, good afternoon. Share your screen. So, okay, yeah, I'll share my screen. Okay. Um, I'm just trying to prepare the screen for sharing. I want to get. Okay. Okay. Let me now share my screen. Okay. Share link. Okay. RDP. Um, okay. Remix. Okay, loaded. Okay, nice one. Now, can you see my screen now? Please, can you see my screen? All right, nice one. So I just want to be able to track whether my screen is on. So that's good. So from the last time I was talking about what's it called? I was talking about the remix ID, how to use it properly. But now I feel like you're already familiar with it since you read through the documentations. So there are some default codes there, which is like what we actually want to make use of very well. Because in the presentation you realize that I was talking about storage. Uh, this is the let me just go straight to this. So assuming you are in the last class, let me this is the home. If you load your for the first time, this is the home. Then from the home you can click this compiler. Inside this compiler, click make sure you put auto compile here. Just click this auto compile. So once you click this auto compile, any source code that you are going to click here is going to be automatically compiled. Look at it. This um, storage.sol. This is the code. So immediately you click storage.sol, it will be automatically compiled. And immediately you click Solana owner.sol, it will be automatically compiled. Now, I will want to use this code to, I just want to explain this code to you. If you if you are just uh but after I explain this code, I want to start from the high level. After explaining the higher level functionality of the code, then I will now go to the lower level in terms of breaking it down from the higher level to the lower level. So if you can understand it from the higher level, what each part of the code does, and then we'll go to the smaller part of the code and some other alternatives that you can use. So the main functionality of this code is a storage uh, program. So this storage program, what it does is that it just makes sure that you are able to um, store some data on the blockchain on the network. So I am once I'm sharing my, let me see whether people are seeing it. Okay, okay, please. You can DM me if you have any idea you want to present. I just want to check whether everyone is still with me. Now, what I'm saying here is that please, are you at this point? Are you at this solidity storage.sol? Have you clicked on it on this storage.sol? If you have clicked on it and you are at this page, just let me know because I want to do some modification and I also want you to do the modification and we just want to understand this code. We want to understand it together. This code has been written directly by default on the Ethereum remix IDE. Okay, I want to increase the brightness on my screen. Brightness. Okay. It will be brighter. I'm coming. Okay, can you see now? Can you see my screen now? Is it brighter now? Okay, I think it's brighter now. I already increased the brightness to the highest. Now, please, are you on this page? Are we on the same smart contract? Are we on the same code? If you log in on this machine, it will take you to this point. And once it takes you to this point, you are going to see some codes at this left section. Click on smart contracts, then click on storage.sol, and it will bring out this to you. Then, if you are here and you already clicked auto compile, it is going to automatically compile the storage.sol code. So I just want us to be on the same page so that you can see what I'm saying and you can interact with what I'm talking about. Okay, so seems like the code on the remix file is different from yours in my end. Uh, why is it different? It's almost the same thing. They always have storage owner.sol, storage.sol, and then ballot.sol. So let's start with this storage.sol. This storage.sol is just to store some number on the network. You want to store some variable on the blockchain. So the first line of code here is a comment. So a comment is a code that is for the developer to understand the code. But in this situation, the comment is um, the comment is just to indicate the license. So now in this case, the license for this code is what's it called? I just write a comment now. I'm writing this comment. This comment will not execute on the network. So it's just like a code that you write to be able to tell yourself some information about the code. So it's just like a metadata. So a metadata is data about data. So this is like information about this code. So the first information here, immediately you see these two signs. Um, it is just telling you that SPDX license identifier is GPL 3.0. So this is the license for this code. Now, then we go to this line of code. What is this line of code doing? This line of code is trying to tell you the compiler version that this symbol is saying that greater than or equal to. This symbol is saying that less than. So the Solidity compiler here the Solidity compiler that can compile this all the codes there, the Solidity compiler that compile all the codes there must be greater than or equal to 0.8.2 or less than 0.9.0. So any compiler from this point to this point can execute or can compile this code to byte codes. Now, in the last lecture, I was talking about how Solidity is going to be converted to the byte codes. When I was showing you the Ethereum virtual machine architecture, that all the solidity that you are writing is still going to be converted to a machine code, which is the bytecode that can be understand, but that can be compiled and executed by the Ethereum virtual machine itself. That can be executed by the Ethereum virtual machine itself. So this Solidity compiler is the one that is going to convert it. This version of Solidity compiler is the one that is going to convert it to what's it called, to Ethereum, um, the Ethereum bytecode. It is this Solidity compiler version that is able to compile this syntax to Ethereum bytecode. So the last time I talked about this guys, okay, the Solidity versions. Like when I was talking about Solidity, when I was talking about Solidity documentation, I was showing you how there are several versions of Solidity since they have started developing Solidity. And this is where I showed you there's a way you can actually select some version here. I don't think I think this is the documentation I used last. Okay, this is it. So you can they have actually changed this interface or okay, okay, I'm the one that actually went straight so you see that's all. Let me just go to so they are forcing this to so this is just like kind of the version of Solidity that I'm trying to show you how the documented different version of the Ethereum. So this is just like the compiler versions. Now let me go straight to this the second line. So look at this block. This is also a form of comment too. This is a comment too. This comment is also giving us information about the code. So this is called a block comment. So the block comment is always like this. The block comment is always like this. So anything between this thing can be anything. So this is a format for block comments. So now we are talking about this is just a line comment. This using two slashes line comment, but using this format. Anything between anything between these two, anything you write in between it is a comment. So that's how we'll just go straight and define all the atoms, all the components inside the code. So by the time we are now explaining Solidity deeply, you'll be able to understand it from scratch. So this is just two types of comments in Solidity: a block comment and then also a line comment. So you can actually comment anything you want to write inside this code. Let's say anything you want to write or any notes you are keeping inside the code just to explain to yourself or others what you are doing. So that's just it, sha. You can see that everything in between this and this is what's it called? It's a comment. Let me just remove this now. Immediately I remove this, you can realize that all the stuff there just became all everything down here. You can see an error here. Everything down here just become green. But if I return it back like that, you realize that it will be normal again and it will automatically compile by the left here. So now we are done with comments and then compiler version specification. You are specifying the compiler version here. Then let's go to something called contracts. Now, one thing I want to show you is that a contract is like the main code. The main code. Okay. So in a contract, there is look at this. You realize that this is the start of the code and this is the end of the code. I want to do something. Mhm. If you can see this properly, can you see this? So you can see that everything in between the um, curly brackets for the open and the close is a contract. Now, the contract is defined as, it's just like you can, like I want to talk in normal terms and I want to talk in computing terms. So you can think of a contract as an object. You can also think of a contract as a software, like it is is the main program that you're writing. So you know all these people, all these Ethereum network, and then all these different blockchain networks, all they can execute is a contract. So the reason why we are saying it's a contract is because it's more of like a set of rules that will be executed on the blockchain, no more, no less. So it is already agreed that when you are writing your programs here, you are saying that this. Let me talk about the first line of code inside the contract. So you are defining the name of this contract to be storage. This is the name of the contract, but you are telling the compiler that it is a contract. So you first of all define, you first of all tell the compiler that this is a contract, and you now tell the contract the name, the compiler the name of the contract. Then you now open the contract and close the contract and define all the functionalities of the contract inside of it. Now, when we are talking about the functionalities, let me take your mind into some abstraction. So if you are into programming, I'm trying to make sure that this course is not because many people here have not written any program before. So I'm trying to make sure that everything I'm talking about is understandable from a very, very basic point of view. So uh, yeah, we are still going to solidity for deeper, but we are starting from the higher level. So now, in this storage, now you have to think about, if you have an idea now, then you want to write a wallet. Hmm? So you want to write a wallet that will store something on the blockchain, that will store money on the blockchain, that will store USDT on the blockchain, or that will store um, Bitcoin on blockchain, that will store anything on the blockchain, or you have an idea that you want to write a program on the blockchain, that the program will be like a calculator. So what you will do is that you will define the contract after specifying the compiler version you are using, that you are making sure that this compiler version is specified. That means that you are saying that everything you are going to write inside this code is going to strictly follow the syntactic rules that is inside this compiler version. All the syntactic rules are here. All the syntactic rules are here in the documentation. All the what's it called? All the rules of, let me find the better solidity documentation. All the rules are here. Look at it there. This is it. So this is like the language description. Anything from here, all the rules here, you are going to follow it. So there are rules for defining variables, external variable functions and library, and there are rules for creating contracts. There are rules for visibility getter. There are rules for function modifier. These are rules that is under 0.8.26. So everything you are going to be doing here must strictly follow the version you are using. It must strictly follow it. Now, that your idea now, you now saying that okay, your idea is calculator, you just make sure that you are writing a smart contract, and the smart contract will be called calculator. You understand like that? But in this form, we are just our idea is that we are trying to build a storage. So what we are doing is that we are storing what? We are storing numbers. This is a very simple idea. We are storing numbers on what? On the blockchain. A very simple idea. So what we do is that we write contracts. We let me try to I want us to write this thing again. I want us to rewrite this code again. But after explaining, I'll just rewrite it again. So this is storage. We just want to store number on the blockchain. Now, for us to store number on the blockchain, there are some syntactic rules that has been defined in the Solidity documentation here. Eh? Now, there are some rules that have been defined. So we just go ahead and we find the rules. We did not know this language, just like let's say this is a technical language actually. But other languages like Russian, like Chinese, like Hausa, like Yoruba, like Igbo languages, they are natural languages. But all those languages, they are also having their own rules to how you are going to speak if you want to say something. Now, but for technical languages, they also have their own rules how you are going to speak when you want to say something. All I'm just trying to let you know is that programming is as easy as talking. It's as easy as telling things. I used to say something. I used to tell people that everyone is a programmer, but it's not everyone that is a computer programmer. So you're a programmer because you can always give instruction and write things that other people can execute. So if you write a manual or step-by-step procedure, or if you have written a program before, let's say a program like a normal program, they used to call it program. So if you're having an event now, you can have the event program. So they could have listed that this is the first thing you will do. Maybe you have to sing at the first opening of the program, then you greet the audience, then you share food, then you dance, then you party. After that, you guys take a picture together. Then that's the end of the event. So that event is already programmed, step by step instruction. So now, when you are thinking about that event, then you can say that okay, that event is like maybe your birthday party is an event. That your birthday party, you already write you are executing that your birthday party from 10 a.m. to 5 p.m. in the evening. So from 10 a.m. So all the activities you are going to perform on that event already written down in your event manual. You already programmed it. So you're also a programmer. But when it comes to computer programming, it is uh, it is almost the same thing, but it's different in because you are more strict in your definitions and you are using a compiler and you are programming a computer, not human beings. And everything you are going to be dealing with is going to like dealing with numbers most of the time. So you are going to be dealing with number. So number one thing is that we have an idea now. Our idea is to write a computer program. Let me write our idea down here. So I want to write our idea down so that we can know what we are doing. So let me use a block comments now. See the way I'm writing the block comments. So the block comments for my idea. So my idea is a software that stores number on the ICP blockchain. Or the Ethereum blockchain. So that's my idea. This is our idea now. This is what we are trying to do. Now, what do we now do? The next thing we do is that we define step one. We define the compiler version, we are going to translate the Solidity code to byte code that can be executed by the blockchain. That's it. So this is step one. We already executed step one here. So this thing now, what we do is that I'm looking for this. No, I don't like this document. This like the listen. They have better documentations. I don't know why they're just giving me this rubbish documentation. So DT docs. I don't like this document. So there's a documentation ahead that they have all the ahead is it all the versions. This is the documentation I'm looking for. They have all the compiler versions and the rules that are guiding them. Look at it. You can see all the versions there from the beginning of Solidity, from version 0.1.2. But those ones are outdated, they are too buggy, and then we want to be we want to this is new software and I want it to be as updated as possible. So we are going to use version 2 0.8.6. Let's look at the version we are using here. We're using version 0.8.2. So that means that this version 0.8.26 is in the middle. It's between version 0.9.0. So that means that that compiler can work for this code. Now that means that we just go straight to look at the rules, or we see this is you can remember that greater than or equal to. That means that we can also use this one, starting from this one up to this one. So we cannot use 0.9.0 in this code. This syntax is not supporting 0.9.0. So we just go straight to select this. So once we select this, we want to see how we can do things with anything there. So just like this is the book now. This is the book. This is like the Bible um for writing in this version. So what do? We go straight to the description, the language description. So I think they are now going to how we are going to structure our contract. Let's go here. Now remember something zero we are you see on this version. Oh. So how are we going to structure our contract idea like this? This is the old documentation. Mhm. They are showing us different stuff. Now let me just go straight to explain this. I think I already spent enough time here. So let's go straight to just this is a variable type called number, integer type. We have to store, we have to create a space that we want to store the number in. Then we have to now create a function that will store the number inside the space. Then, these are comments. These are comments. Then we also retrieve the number. We have to create a function that will retrieve the number from the space. So for all these ones, there's a gas fee. This is a gas fee attached to it. This is a gas fee attached to it in GUI. Sorry, this you can see the gas fee attached. The cost of performing this operation on the network and the cost of performing this operation on the network. So this is just a space where we are saying that we need this amount of characters inside the network to space to store our number. And once we have stored the number, we want to retrieve the number. So now that idea now is that we want to store number on the ICP blockchain or Ethereum blockchain and retrieve it. So this is the code for the idea. It's as simple as creating the smart contract that will encompass the variable and the functions. So the variable, this is a variable. The variable is like kind of a space or a bucket by which you are going to store some values. So, when you want to store something of value that worth a spoon, you can store it in just a spoon space. And when you want to store something worth more, if you need more space for bigger numbers. So now let me just, I think I'm done with this one. Let me now go. These things have all these syntax. They have their own rules. I think we already learned with it here. So let's talk about the rules for variables. This is the rule for variables. Hmm? These rules, these ones are rules, but I already talked about it. Talking about the license, how you specify the license is already here. Is already here. But let me just go to the rules for the variables. So the rules for the variables is like we are talking about state variables. So these state variables values are permanently stored in blockchain on the contract storage. So immediately you create a contract and you deploy it, the contract is going to create collect space on the network, and the space that it is containing to just take enough space for its variables to be stored in. So any type of program you are writing, either normal manual program or blockchain program or AI, anything, you are going to use storage. You are going to have access to data. You are going to use data. And once you are using data, you are going to store your data in some variables. And data is in different formats. If you're into any scientific field, you have gone through statistics before, you understand different type of data, variables, data. So now in these state variables, what is going on is that you can define state variables as this is the simplest integer state variable, unit of integers. Well, these guys are not giving me enough details on integers, but let me just go straight to tell you about different type of integers. And there's long integer, there's u long integer, there's this way are not detailed enough. I think they should give me more information about integers here. And there's a unit integer, and apart from numbers, you can also store strings. So those are also variables. But this documentation is not really. I don't like what they are writing here. They are so not. They're not informative enough. I really wish it's informative enough. But I have written all these things in a document that I will share with you after the whole lecture. I'll share that document so that you can go straight to do it. So now let me just leave this and then deploy this contract. Let me deploy the contract. So for you to deploy a contract, this simple contract, now for you to deploy it, you will go to this point. You already put the auto compile here. Make sure that your compiler version is synchronized with this. This can still compile this because in the middle of this and this can 0.8.2 you can still compile. So it's already compiled here. If I remove auto compile now and click it back, you see that it's already compiled. Look at it. Look at this place. Look at this. So immediately I click it back, it compile. So after compilation, what do you want to do? You want to I don't want us to go through all this analysis yet. We want to deploy. Click here, you want to deploy. So we are not yet deploying on the main network, but we are still using the virtual machine, the simulated Ethereum network. So for us to deploy, we have to make sure that we are seeing the same name of our smart contracts as we are seeing it um, as you are saying it on this, make sure that you are, because in programming sometimes you may be exhausted and you are not tracking the you may be compiling this, you may look at it, this is compiling and to compile, this is a new program entirely, it has compiled, but you notice that this is different, but this is what you want to deploy. Make sure that what you want to deploy is what you compiled. So immediately you compress pull deploy, is going to deploy to the network. This is not real network, it's still like testnet. This is a simulated version of testnet on Remix networks. When you click deploy, you can see the green light there, the green button there, showing that it has been deployed. This is it. This is the details of your deployment. I want to explain what is going on inside this deployment. I just want you to relax. See, we will get all the details inside this thing. So immediately you click that deploy. What happened is that your code is being compiled. Number one, compiled. After being compiled, look at it. Look at the. Let me show you the compiled version of this. Sorry, dot JSON. This is the build. This is the compiled version. This is the build information. It's being compiled to bytecode, deployed bytecode. So after it has been compiled, then you deployed it. So after when we click that deploy, then what happened is that we went straight to the network. We sent our smart contract to the network. So this storage has a constructor that sent it to the network. And once a transaction enters a network, it has a transaction hash. This is a transaction hash shortly. And this is a block number that executed it. And the contract that you just deployed has an address on the blockchain. So this address that the contract is having on the blockchain is like an identifier of every, there's a way Ethereum virtual machine will be able to keep track of all the software that is running inside of it. Ethereum virtual machine is more of like an operating system. So it must be able to keep track of all the programs that are running inside of it with what? An address, like keeping track of your home address. You are inside a city, and that your home address is what we can use to track you or track your address. So this is the contract address. This contract we just deployed, this is the address on the network. The same thing will happen on the main network too. So this is the contract address. And address from this is the wallet that deployed it. Wallet address that deployed what? This contract. In blockchain, everything is more like a transaction. So if you are deploying a contract, you are deploying from a network. If you are deploying a contract on a network, you are deploying from your wallet. You must have a wallet address. You must have an account. So sometimes it's a wallet, sometimes just most of the time it's a wallet because you will have to pay for the transaction that you are doing. You have to pay for the deployment. So that your storage contract, you remember in our storage contract, we can see the amount of money that we are going to pay for storing a number, which is 22520 GUI. It is a gas, but they call it GUI in Ethereum because it's a fraction of Ether that is going to be paid. And for you to, these two operations are costly because they are going to cost the network computational resources, and those computational resources you are going to pay for them. That's why you use uh, wallet address. So this wallet address must have enough money to deploy the transaction. If there's not enough money there, it is going to fail. The transaction is going to fail. So now from this address to this constructor, so this is the gas, this is the total amount of gas that you use to deploy it. I mean the transaction cost. This is the total transaction cost.
This is the execution cost. If you want to execute that contract, for executing that contract, this is the execution cost. So I think it's a combination of this and this and this. So that's why they put it there that this is the execution cost. So now these are like deploy information anytime you deploy a smart contract on the Ethereum network. Now we are also going to do that same thing for ICP for you to have, but today next week is like full ICP, like that next week is 100% ICP. But today I just want you to understand what's going on in a very, very low level. So this is the output. What is there is like the full hash. The full hash is like this is your code. This is the code. This is the code. Now, if you are logging on this net, if you are logging, if this contract is logging some data, it will be shown here, but it's not logging anything. Now, I think this is as simple as I can just give a higher level overview of the whole thing. Now, let me pull up I have a lecture notes here. I'll pull up some. I will try to send this lecture notes to the group so that you can just read it. It's very clear and concise and like simple. You can replicate. You can always replicate the what's it called? Why is this thing just that? Okay. Okay. Now you can always replicate the codes that's inside the lecture notes and test it out on your own and understand things that are there. Now let's dive a bit deeper. Please, if you get me up to this point, can you just raise your hand? This is like a simple high level overview of a smart contract. Like a simple high level overview of a smart contract. So for you to define a function, you are telling the compiler that this is a function. And the function you have to call the name of the function. The name of the function is called store. Then what this the when you are talking in terms of a function, you think about it as anytime you want to write a function, just think about it as input and output. And then a function is different from a method, but they are similar. But a function is always going to give you always going to have an input and there's going to be an output. So the input to this function is the number that is going to be stored. And this is like more of like a method actually, sha, but the input is a number that is going to be stored, which is uh, num, and it's a public. The type of so when this is a function and this is the type of function, it's a public function. What it means by public function is that this function immediately you deploy it on the blockchain, other people can use the function. They can connect to your smart contract and call this function. So they can use it to store their own numbers on the network. So you have written a program now and you have deployed the program. Let me see whether we can interact with it here. Okay, let's interact with it. Look at it now. Can you see? This is the storage program. So can you see now? This is the simple interface to interact with this storage program here. Do you notice that there are two functionalities here? This one you can store by putting the num here. You can see the num. You can put it in and send. So if you want to store, I want to store 777. If I click transact, what happens is that you can see it here. It is a public function that I am using now to do what? To send a transaction to the network again. I'm sending the transaction to the network. I just did what? I just executed the transaction now. I just used this program, this our idea, this our program that I use it to do what? It's a public function that is used. So a public function is a function that other people can use, other addresses can use. Any address that is not this address, that is not the owner of the contract. This is the contract. This is the owner of the contract, the one that deployed the contract. Look at it. You can see this account. This is the account that deployed it. The account has 100 Ether on it before, but the 100 Ether has been deducted immediately. We use it to deploy. We have spent part of the money inside our wallet. Look at the last four digits here. It's DDC4. The last four digits here too is here. Can you see it? DDC4. So that means that this I'm still the owner of this contract because I'm the one that deployed this on the network. So um let's move on to the interaction with the network. Now I have sent 777, which is a number I've stored it on the Ethereum network or on the ICP network. I've stored it there. Then I want to retrieve the number. What will I do? For me to be able to do that functionality that I retrieve, I have to write a code that will do that too. Everything you do in programming, you are responsible for everything. So that's like, in programming, there's no free lunch. Like the only thing is that there are abstraction are people that have written some code that you can leverage in terms of libraries, which you are also going to get into very soon. You can use some libraries. Like libraries, a block of codes that have been written by other developers that you can now use. You can call and use in your own personal code. But the truth of the matter is that any functionality you are looking for in your program must be accounted for by a function or a method. You must implement it. So, like I've said in your program of your, like I explained something about you having an event and you have written a program for the event, your birthday event. So, there's a step by step as everything is going to go to the end of the event. And all those things, some people are going to perform that activity. Now, in this case, as a computer programmer, it is the computer that is going to perform those activity. And in this case, as a blockchain programmer, it is the blockchain that is going to perform those activity. So now, what is going on is that you are also going to write another function. You have written a function here that stores the program, that stores the number. You're also going to write another function that retrieve the number. So when you want to write a function that retrieve the number, what you are going to do is that think about it. Just think about it. Take a thought. Just think about it. If you want to write a program, if you want to write a program that retrieve a number from the blockchain, what will you do? Like, just think about it. What you will do is that you will first of all look for the address of what's it called? That contract that stored historic contract that stored the number, and look for the public variables that are there or public functions that are there. So this is a view that returns number. This is a public view. So this is a public function. This is a type of function. This this is the name. This is like an identifier for the blockchain to know that it is a function you are trying to define. You are defining it, and you are giving the name of the function that is going to be a retriever. Retrieve. So that's, you can call it anything you want based on what you want to do with it. And you are saying that this function is of type public and is of type view. Is of type public view. So what you mean by view is that is a type of function that returns data user at the other end. So view can be expatiated, like you can have different type of view function, public view function. And those functions, the most common characteristics of them is that they are always returning the data to the user. So this is the function that is going to return this data to the user. And what this is the what's it called, the type of data. I mean, specifying the amount of chunk of bytes of data that is going to be returned. You are specifying it here, and you are returning number. The reason why you are using this number directly is because it's already defined here. So this is like a global variable here. So you are saying that because this is still like it's still inside the same program, so you can have access to it. Then we still go deeper to other stuff that are not inside your own program, but it's a public variable. Yeah, you can have access to on the blockchain. There's a way you also retrieve that. But this is just the definition of the function that retrieves the numbers that are stored on the network. So if you want to retrieve this number, this is the function that you're going to immediately you click this now, it's going to retrieve the 77. Remember, as I you notice that as I clicked it, there's a transaction that was performed again. So every transaction either read or write. So this is a read transaction, and this storage is a write transaction. This is write, this is read. Those are the two, in computing. If you want to write a simple program, you must know how to read to the to write to the memory and read from the memory. So these are the two functionality of reading. These are the two functionality of writing and reading from the blockchain. So today we're able to cover reading and writing on the blockchain. Then we're also going to talk about more nitty-gritties on the Solidity and how you can use Solidity for the ICP network. So this same thing, this same program now, we also try to do the same thing um, for the what's it called? We are trying to do the same thing for the network, for the ICP network. So we are doing this for Ethereum network now. We're also going to do it for ICP. Okay. Please, is there any question? Let me try to comment. Is there any question from everything I've explained so far before I go to the ICP? Any question? Any question? Okay, so in fact there's no question, let me just now explain more about the ICP. Mm, okay. Okay, I see one question now. Scalability is scalability. So you are asking that what scalability means in blockchain. Scalability is just scalability, like scalability in blockchain is still scalability in software. So what it means is that you know it is all about being able to be adaptive to request like response. Like if you have let's talk about data scalability. Data scalability. There's data scalability, there's computational scalability. So when we are talking about data scalability, is that is your storage going to scale with the demand for storage? That's data scalability. And when we are talking about computational scalability, is your computational power going to scale with demand for computational power? So what I mean by storage is that you can see in our new, in our simple program now, that we are storing just a variable and we are retrieving a variable. And for us to store a variable, we will need you can see the u. This is the amount of memory we need on the blockchain, 2256 unit integer. So there's a way it is in the bytecode representation. Unit integer 256. So you need that space to store just one number. You need that space to store one number. Now there are some programs that those programs are very, 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 very I don't know why the stuff stopped presenting. It just stopped presenting. I don't know why. Okay. So those programs are very, very, very um, data intensive, like AI systems, like big data intensive. So some network will not be able to handle that. Some blockchain network will not be able to handle that. So they are not able to scale with memory, with storage. They are not able to do storage scalability. They are not able to scale with storage. But there are some data that are actually there are some network that they can do computational scalability, but not storage scalability. There are some that can. So let's talk about computational scalability now. Computational scalability is like when
Hello, Mr. Damilola. Can you hear me?
there's an operation that we are performing read and write. Now there's a section in computer science called big O notation, how to measure performance of an algorithm if you are into computing here. So there are some programs that will be computationally intensive, like they have a lot of read write operations that once there are more users, they are going to consume the clock speed of the CPU of the computer. So those computational speed. Oh, my screen is showing blank. Oh God. Maybe this network. Those computational speed. Okay, let me try to share again. All right. So those computations. Okay, let me just round up. Oh God. So those computations are okay. Let me introduce. Okay, I think have I answered your question? Have I answered your question about computation scalability? So storage scalability and computation scalability. So storage scalability, I already explained that. So computational scalability is the read and write operations consumes clock speed. So there are some CPUs that are not going to be able to scale. I told you last week that when you're talking about scalability is on software and hardware level. So the hardware level is like the main computer that the infrastructure backing it up if it's able to handle the request on it. both either story request or computational request. So um, that is it about scalability. So a scalable system is something that is going to like look at. Let me show you a scalability graph. If you are using AWS, if you are using AWS systems, you will see some things like this. Can you see my? This is like a distributed database. Yeah. Can you see? What you can notice in all these things is that depending on what is on your y-axis, if you are scaling in relation to how many reusers or how many requests are coming to the software. So type of scale. So there are some programs that scale linearly in terms of big O notation, in terms of combination, like the computational uh, efficiency. Now, when you're not talking about scalability, blockchain scalability, if all these are blockchains types now, so we are measuring scalability against one variable, which is like request or data. Like, can we scale with data? The more intense data, can we scale with more intense request to read and write? So, or both together. So this is like kind of this is what you are looking for. You're looking for something that is linear. Sometimes you want something that's like this, that is logarithmic, just based on your interest. So that's that about scalability. I will send the notes. I will send the notes so you can have a full understanding of everything. So before, let me make sure that I open the grant for ICP. Let us quickly read the ICP, what's it called? ICP blockchain together. Now, this is ICP blockchain. Let's talk about, let's develop with it. So, ICP programming languages and ICP sample codes. This is it. This is ICP for you. So, by the time, by next week, I am going to work on. I wish you just because that will be the end of the whole thing. I wish you like kind of go through this documentation here and read through ICP. So now, do you know that this? Let me just find the sample code level beginner domain. Let me say, let me find one simple stuff. Metaverse and NFT. For language, JavaScript. So next week we are going to touch on JavaScript and then the now some code for that. Let me see websites. Language, yes. So next week we are going to talk about how to host NFTs or and websites, how to host website on ICP. So this is like I just want to give an example of I want to explain some codes here. Um, let me, okay. I don't have enough time here. I think we're all familiar with JS and JavaScript. So we are going to replicate this simple website next week. So basically, we are going to be using this ICP SDK. Do you understand? We are going to be using this ICP SDK. And that website, inside this website, we are going to write something that is going to store like this code that we say. We are going to write this in JavaScript. It's going to store a variable on the network, on ICP network, like a normal website. The website is going to have a click button that will store and retrieve, read and write on what? On ICP network. And we are going to deploy the website on ICP network. But this is like a very detailed stuff that will be needed. So this link will be sent to the group, but you need to just go straight to this and understand what is there. And then from there, we can now more have more have more detailed stuff about creating contracts and then deploying the contract and comparing the contract on ICP. So that will be next week operations. Thank you. Have a very good time. I hope I'm able to just simplify everything as clear as possible. Thank you for coming to the lectures today. I really appreciate it. Have a nice day. Bye.